This will be quiz number 9. First question, what is a vector? From our textbook, a vector is a directed line segment. So you could have said that with an initial point and a terminal point. Or simply that a vector is some magnitude and some direction. Either of those is sufficient. Number 2, given a vector with an initial point of 3, 2 and a terminal point of 7, -1, find an equivalent vector whose initial point is 0, 0. Well, all we got to do is subtract the terminal point from the initial point. So subtracting the terminal x, which is 7, from the initial x, which is 3. The terminal y, -1, from the initial y, 2. You're left with 4, -3. That is the vector in standard position, which we could also represent as 4i plus -3j or -3j. This problem is asking us for this form right here. Number 3, determine whether the two vectors u and v are equal, where u has an initial point a and b, and v has an initial point c. U has an initial point a and a terminal point b. V has an initial point c and a terminal point d. Well, you may notice that a and b are exactly the same as this one from number 2. Did that on purpose to decrease your work a little bit. So u, vector u, can be represented in standard position in component form as 4, -3. So we just want to see if this next one, v, has that same standard form. So we simply need to subtract the x's and y's again. So 8 minus 4, the terminal minus the initial, is 4. -5 minus -2 is -5 plus 2, that is -3. So if we were to bother to graph these, we could see that they are parallel to each other and they're the same length. So if we moved them to the origin, they would be right on top of each other. U is equal to V. All right, number 4, find a vector that is half the length of this one in the same direction. So to find a vector that is half of vector V, which is -4i plus 3j, we simply divide both of our components into 1/2 of v is equal to -2i plus 3/2j, or 1.5, however you want to write that. And that's it. If we wanted a vector in the opposite direction, we would simply negate both of the signs. It's not asking for this, but might need to know that. It would be positive 4i, don't need the plus, minus 3j. That would be the same length in the opposite direction. Number 5, find the magnitude and direction of the vector 6, 8. Well, let's call it vector v. Say vector v is 6, 8. To find the magnitude, we represent it what looks like absolute value signs. We simply take the square root of the square of both of the components. Essentially, it's the Pythagorean theorem. You can think of the vector, the length of the vector, as the hypotenuse of a right triangle. So that's 36 plus 64. That's 100. And the square root of 100 is 10. That is the magnitude or the length of that vector. The direction we take, we can consider this going from the origin, going out 6, and going up 8. Here's the vector. So this angle is what we're interested in. I call it theta. Well, from this angle theta, we're talking about the opposite and the adjacent side. Well, that's tangent. So tangent of theta is equal to 8 over 6. Thus, the inverse tangent of 8 over 6 will be theta. And you should see it's going to be a little bit more than 45 degrees because this side's a little bit longer than this side. Just come to any browser. Inverse tan of 8 over 6. And this is going to be the same as the example problem we did because 8 over 6 reduces to 4 over 3. In degree. 53 degrees approximately. So theta is about 53 degrees. And that concludes this video.